recording is on. Okay, so think about your laptop or my laptop. Like in my laptop, the processor is Intel Core i7. So Core i7 Intel processor is microcomputer system. So microprocessor is the brain, but it is not all. It needs other support, peripheral support, memory support, input-output support, many things. So this is a complete microcomputer. What are the things are there and how all the things together work? So this is about the history about the Durex microprocessor. We already discussed it long at the beginning chapter, introduction chapter. Like this is a Durex microprocessor IC, 40 pin IC, and this is, I mean, basic information, and it can work in a minimum mode or maximum mode. So minimum mode, so there is a pin, this pin, like you can see minimum slash mx with a bar. So that means if this pin is 1, then it works in a minimum mode. If this pin is 0, then it works in a maximum mode. Okay, so it is like that. So that means it can work in a minimum mode, and what it can work in a maximum mode. Just one pin actually determined. If you connect it to the VCC or 5 volt, that means it is in minimum mode, and if you connect it to the ground, that means it works in a maximum mode. So what is minimum mode and what is maximum? Minimum mode is a single microprocessor system. I mean, if you need it, I mean, normal operation. So one microprocessor normally, like you know, in all PC, laptop, desktop, it has a one processor. In a motherboard, there is a one processor. But sometimes, you know, like if I mean the microcomputer, it needs for high performance requirement, something like that. It may have more than one processor. That is called maximum mode. So that means it is a multiple processor system. Maximum mode means multiple processor system. So anyway, so mostly actually it is a minimum mode. That means this pin, it must be 1. Okay, so if we summarize the all the pins of the of the microprocessor, we can see what are the things are there. So it can be grouped in 5 group more normally. So one group is address or data bus. You know, address or data bus. Here actually AD0 to AD15. So 16 pin, they can be used for address. They can be used for data. That's why it is called AD0 to AD15. So that means same pin. Sometimes we microprocessor sometimes use it for address. Same pin microprocessor sometimes used for data. So that's why, you know, like this is the benefit. This is the output of the technology. You know, technology makes the things smaller but more functional. So IC is 40 pin IC, but it has, so that means it has only 40 pin IC microprocessor, but it can do many work than a previous microprocessor. What is previous than this microprocessor? You can see, and also it is compact, more smaller size. Like this is one of the indication. Like, you know, we can see that 16 pin. They 0 to 15, you can, so 16 pin, they can be used for address and they can be used. So that is multifunction. Same pin, we can use it for multifunction. And also you can see there are another 4 pin, because address bus, data bus is okay. 16-bit data bus is okay, but address bus 16-bit address bus is 20-bit. So you can see that A16 to A19, they are also multiplexed with S3 to S6. So S is for status signal. So status signal, status signal 3 to status signal 6, they are multiplexed with it. So that means these 4 pin, they can be used for address, address pin A16 to A19, Also, they can be used for status signal S3 to S6. Okay, so this is about address and data bus. So this is one group. And then status signal, this is another group. Then another signal, it is called control signal. So control signal, you can see these are the control signal. These are the control signal, memory or input output control signals. So look at here we have a few pins. One is called ALE. What does it mean? We'll discuss it later. And one is called BHE with a bar, BHE, bank high enable with a bar, this can see, or slash S7. So it is so bank this signal, that means this pin, it can work for BHE, and also it can work for status signal 7. Okay, there is another pin, it's called memory or input output bar. So that means if memory related operation, then this signal is 1. If it is input output related operation, then this signal is 0. Okay, and also you can see there is a one pin is called DT slash R bar. So that means if it is 1, that means it is a data transfer mode. If it is 0, it is a receiver mode. We will discuss later. Okay, and there is a one signal, it is for read signal, one signal for write signal, and one signal for DEN, data enable signal with a bar. That means if it is 0, then it is active. And there is another signal, it's a ready signal, but this is input signal for the microprocessor. All the control signal are output signal except this ready signal. So this is about the input output, control signal, memory or input output related control signal. So this signal actually basically we'll study, we'll see. And there is some interrupt signal also, interrupt signal. As we don't have time, we will not go this chapter, this interrupt signal. So we're not going details, but we're discussing these signals. And one is called DMA, direct memory access. So here is also we have hold signal and hold acknowledgement signal. This is also due to the shortage of time, we will not go this discussion also. So these two category, interrupt signal and DMA signal, we are not going to discuss. And this one is actually, we said already, minimum or maximum mode. If it is 1, that means you must have to connect it to the VCC. That means it is in a minimum mode. Okay, so this is a basic idea. And power supply, like it needs a ground supply and VCC supply. If VCC 5 volt, then 5 volt, 9 volt, 9 volt. It depends on the what kind of IC it is. Okay, so yeah, let us discuss this address and data bus with this control signal. Okay, so address and data bus. So you know that AD0 to AD15, as I said you before, they are used for address and they are used for data. So at the beginning, actually, it is used for address for any kind of operation. At the beginning, this signal, this 16 pin, they are used for address, and later on they are used for data. That's why it is called multiplex address data bus. Okay, so multiplex, how actually it works? So let me discuss it with drawing, then hopefully it will be, yeah, okay. So if you look at here, okay, let me draw it here. Okay, I'm drawing something. So wait. Okay, so now look at here. This is the simple picture about, I mean, how this address and data lines, they are work together, same pin. So look at here, this is address and data line. If I use the different color, yeah. So if you look at here, this one is the same line, address and data line. Okay, so okay, one thing is this is called latch. A T C H latch, and this one is called transceiver. Okay, and this one is microprocessor. Okay, so now look at here, this is 16 pin AD0 to AD15. At the beginning, microprocessor send the ALE signal. What is ALE? Look, you can see here elaboration, address, latch, enable. That actually enable these latches, address latches. What will happen? Latches is like a gate. It actually, so it is enable, it is active, means it opens the gate. So microprocessor, it sends the address signal, address information in this 16 pin. Okay, so then what will happen, as latches are active, so all the address information from input, it will pass through the output, and it is, so that means output of the latch is just only address, A0 to A15. So at the beginning of any operation, mostly memory related or input output related operation, we say that it needs the address. So address information microprocessor, it put in these pins. Okay, in the same pin, 16 pin, same this 16 pin, it put information there, and then, and or at the same time ALE signal is also sent by the microprocessor to activate the latches. So once the latches are active, all the address in this in these lines, in these 16 pins or 16 lines, all the input, all the address information, they are now passed to the output of the latches. So for short time, and then ALE signal is, it becomes inactive or it becomes low. And during the active time, it is high. Then latches are active, and then it becomes ALE signal, it becomes 0. So latches are inactive. So no address information can go out. So once the address information is done, so then we microprocessor use it for data signal. Okay, so then what will happen? Because latches are inactive, so data information cannot go and mix with the address information. So data is now for here. You can see this is for data. Okay, so this data. So so data information is input information for transceiver. So transceiver actually, so here actually how the data information is, they are available here. Output of the transceiver is data, D0 to D50. How can they separate this transceiver signal? This is also IC, another IC. How can it is active? So it is active using this DEN signal. You can see DEN signal. This is the input to the transceiver. Input signal to the transceiver. So as it is with a bar, that means it becomes 0. When it becomes 0, transceiver is active. So once the transceiver is active, then all the data information, they can pass through the data buses. So the address bus and data bus. So after the latches, it is completely address bus, and after the transceiver, it is completely data bus. And what about this signal? You can see there is another control signal, data transfer / receiver. look at here, data transfer slash receiver. So because you know data bus, it is also input signal for the latch transceiver. You can see this is also input signal for transceiver. It actually controls the direction of the data, because you know data bus, for read operation and write operation, data can go to the outside from the microprocessor, or data can come to the microprocessor. So transfer mode is, you know, like that means it is a data is moving from the microprocessor. If data is coming to the microprocessor, then let me see, this signal is low. If data is moving from the microprocessor, this signal is high. Is that clear? So in a short way, is it clear? So three control signal: ALE, data transfer receiver, and DEN, and how they works with latch and transceiver to separate the address information and data information. So is it okay? Guys, is it okay? So that means this is the way actually the things work. This control signal. So here actually we discuss three control signal there. One is ALE. What is the function of ALE now? We can see what is the function of ALE. So at the beginning of any operation, microprocessor put the address information on the address and data bus. Okay, multiplex address and data bus. And ALE signal is high to activate the latch, and address information, they passes to the output of the latches, and it becomes just completely address information. And then this ALE signal is low to inactivate the latches. So we will see it. So details. And then what is the function of data transfer or receiver? It actually, because data moves from microprocessor towards the memory or input output system, or data can come to the microprocessor, from memory or input output system. So that means this actually it controls the direction. And DEN is for data enable. DEN for data enable. So this signal is a active low signal, and when actually the data info microprocessor puts the data information on the address data bus, multiplex address data bus. So DEN signal is low to activate the transceiver, so that the data information on this, I mean these buses, these pins AD0 to 15, they are ready for data. Okay, and a few other there is few more control signal we'll discuss later. And you know, this one is for read and this one is for write, because we know we may have read operation, we may have write operation, maybe memory related, maybe input output related. We will discuss it. Okay, now look at here what I shortly wrote in the previous page. It is like that. You can see that this is a microprocessor unit. Okay, and look at here, this AD0 to AD15. So this multiplex address and data bus, they are connected to the latch, shortly latch, but it is octal latch. IC number is 74373. Doesn't matter, latch. And there is also transceiver. Okay, its IC number is 8286. Anyway, so and you can see this address data bus. They are here connected, and also it is connected to the transceiver also. Okay, they are also connected to the transceiver, and latches are connected to the control signal ALE, and transceiver is connected to the control signal DEN bar and data transfer or receiver. So this is I say, and so then output of the latch is just only address information or address bus, and output of the transceiver is just only data bus. Is it okay? I mean, shortly we can what I wrote in the previous page, it is like that. Clear, right? Okay. Now look at here. Let us discuss the details. What is the function of ALE? As the first step of any operation where actually it accesses memory or port, microprocessor 8086 microprocessor sends out the lower 16-bit of address on the multiplex address and data bus, and external latches such as octal latch. Anyway, octal latch, they are used to grab the address and hold it during the rest of the operation. Okay, so that means this is the function. This is yeah. To stroke this latch at the proper time, micro 8086 sends out a control signal called address latch enable, and once the address information is stored on the output of the latches, the 8086 removes the address from the bus and use it for data, use it for reading or writing data. Okay, so this is the function of ALE. Shortly, you can write it in your own way, but main information should be clear. So this is the function of ALE. Okay, so that means at the first step of any operation, when whether it is where it accesses memory or port, the microprocessor sends out the 16-bit address information on the multiplex address and data bus. So external latches, octal latches like latch, they are used to grab the address and hold it during the rest of the operation. And now how can they, they hold the address? So using the address latch enable, to stop these latches or to activate these latches at the proper time, microprocessor 8086 sends out the control signal called address latch enable. Once these addresses are stored on the output of the latches, microprocessor removes the address from the bus. Now, so these multiplex buses, they are used for they will not be used for address anymore. It is used for data, reading or writing data. Okay, so this is about the ALE, and yeah, so these are more information about the IC. So we are not going details. This is actually yeah. So there is another signal. It's called data transfer or slash receiver. So it is the input signal for this transceiver IC. You know, it actually it is a transceiver IC. It is a bidirectional 3-state buffer. Why actually it is bidirectional? Because you know data can move from microprocessor towards the memory or input output system, or data can come to the microprocessor from memory or input output system. It depends on read operation or write operation. Okay, so data transfer or receiver, it actually controls the direction. Main thing is it controls the direction in which data will pass through the buffer. So this is a buffer actually. Transceiver, it is also called 3-state buffer. Okay, 3-state buffer. So buffer is like a gate, you know, same like kind of latch also. So buffer is like 3-state. So it may be 1, it may be 0, or it may be high impedance. So that means when actually there is no use of it, then it is actually in a high impedance mode. That's why it's called 3-state mode. So that means when the signal is high, that means it is a transfer mode. Buffers are set to transfer data from microprocessor towards the memory. Memory may be ROM, RAM, or ports, input output, where actually input output is connected. And when this signal is low, buffers are set to allow data into the microprocessor from the memory or ports. Okay, so this is about the data transfer slash. And what is the function of DEN, data enable? So this it actually activates the buffer. The buffer used on the data bus have 3-state output. so that it floats the data bus having high impedance when they are used for the other operation, like the like when actually address data bus, they are used for the address information, so they are in floating mode. So floating mode means actually high impedance mode. So this is called one state. And what about the other two state? It may be 1, it may be 0. So 1, 0 and high impedance mode, that's why it is called 3-state output. So for example, the data bus are not enabled for data when they are used for address bus, as I said to you. So DEN signal, it is used to enable the 3-state output on the data bus at appropriate time. Because when there is data signal on the multiplex address data bus, so it actually becomes low. Microprocessor make a low signal to the the data transfer receiver IC, so that data information can pass through this buffer. Okay, so these are the so we discussed 3 control signal. So here about more details about the IC, we are not going to discuss about it. Okay, so and there is another signal, it's called ready control signal. So okay, I will discuss it later. Ready control signal. Okay, and there is another signal, it is called bank high enable. So what is the purpose of bank high enable signal? You know that we know that address memory, this memory is like a chunk, like a normally we understand that, so far we understand that memory is like from the yeah, think about like that, it's like a I mean like a block, they are consecutive to each other. So like 0, this is a 0, 0 location, 1 location, 2 location, 3, 4, 5, so on. Okay, so it's kind of like that memory, but actually it is not. It is memory is logically memory is implemented. I mean, this is normally we understand, but actually it is like that. So it is like that even address memories are in a block and odd address memories are another block. Okay, so 0, 2, 4 and then FFFFE, last address FFFFE, and 1, 3, 5 and last is FFFF. So all the odd addresses, address memory location, they are in one block, and even address memory location, they are in another block. And you know that for even location, so A naught is 0, always 0, because you can see 0, 0, 0, 0, 0, H, okay, in hexadecimal. So LSB bit is 0 here. And what about for 2? For 2, it is 0, 0, 0, 0, 2. So 2 is 1, 0. Okay, 2 is 0, 0, 1, 0. So here is also A naught is 0. So A naught is 0. So that means A naught is connected to this this even address block, and bank high enable is connected to the odd address block. So what happened when A naught is, so that means these two together actually controls, these two together controls the which block, even address block or odd address block. You can see there. So if both are 0, that means we'll use both even an address and odd address. That means whole word. It is used for 16-bit operation, for 16-bit word operation, 16-bit data operation, read or write. So these two, I mean, both bank high enable and A naught, they are 0 together. And if it is 0 and it is 1, that means it actually activate the odd address info. Okay, odd address memory bank. If it is 1 and it is 0, So 0 means the, I mean, even address memory bank. It is activate the even, and if both are 1, that means nothing is active. So is it okay? Do you understand this one? What is called bank high enable? What is the function of bank high enable? It works with a NOT signal to activate the low odd address and even address memory bank. Clear? Is it okay? Guys, it is okay? If you have a question, ask me. Okay, so look at here. So even address, another thing is actually you can see that the data bus is 16-bit, right? So 16-bit, out of 16-bit, so lower 8-bit D0 to D7, they are connected to the odd address memory bank, even address memory bank, and D8 to D15, this higher 8-bit of data bus, they are connected to even address memory bank. So now it is clear, right? So that means this, I mean, if we want to discuss the function of bank high enable, I think is we can draw this figure, and then it will be more clear to us that how actually things are controlled. So that means bank high enable, it is used to activate the odd address memory bank. Okay, so this is like that. And let us go to the another point, and then we'll, so read machine cycle and write machine cycle timing diagram. Look at here. For example, this is the clock signal. Okay, they work with a clock. So one clock, this that means one period. Second clock T2, T3, and T4. In between, there is something TW, wait state. I will tell you later. Okay, so all right. This is about the read operation. Read. It may be memory read operation here. What is the timing diagram of the control signal for read operation? Read operation. Okay, so let us see, for example, move. So look at here, this example. So, and also, okay, so look at here, there is a two example. One is memory read operation. Look at here, memory, square bracket, that means memory related operation, and it is memory data, it will come to the microprocessor address, a microprocessor register AL. So this is memory read operation. And one is called input read, input output read operation. You can see that this is in AL comma 1010H. So 10H is the address of the port where the input device is connected. Okay, so that means this is the input output read operation, and this is memory read operation. Is that clear? Both are read operation. Okay, both are read operation. Is it clear? Yes. So here actually that means data is coming to the microprocessor, because AL is part of the microprocessor. That is coming to. Let us see all the control signal. So one is minimum or maximum mode. As you know, like mostly it is a single microprocessor system, so it is a minimum mode. For minimum mode, this signal should be high. So look at here. So all this becomes high throughout the T4. Normally T1, T2, T3, T4. So four clock pulse is required for completing a operation, either memory related or input output related, read or write, whatever control whatever operation is there. So 4 clock pulse is there normally. So that's why 4 clock pulse, T1, T2, T3 and T4. Okay, and as it is a minimum mode, that means the signal is high throughout from T1 to T4. And then what about the memory or input output? Memory M/IO bar. So IO bar means if it is input output related operation, it is 0. If it is memory related operation, it is 1. So look at here. If, for example, it is a memory read operation, first one, move AL comma square bracket 2010. So that means if it is memory related operation, it becomes 1 throughout the time. But if it is input output related operation like in AL comma 10, it becomes low. Something, for example, at the beginning it is high, then rest of the time it is low. It is like that. Okay, is it clear? So if either it is, if you have to look at it, is it a memory operation, memory related read, or input output related read? Okay. Okay, then yeah, then data transfer or receiver. This one, you know, like as it, so is it coming towards the, so during the read operation, data is coming to the microprocessor. That means microprocessor in a receiver mode, and for receiver it is a bar. That's why it becomes low throughout throughout the time. It becomes low until you can finish it T4. Doesn't matter that. Okay, it's like that. And then what about the address pin and data pin? Look, 80 to 8015. So they are just during the T1 time. During the T1 time, it is used for address. It is used for address only. And then during the T2 time, it becomes float. And rest of the time, it is used for data. So we can continue it until the 4. Doesn't matter until the 4. Okay. So now look at here. So that means during the T1 time, it is used for that address. That means during this time, address latch enable, it is high, so that address latches are active and address information on the multiplex address and data bus, they can move out towards the output of the latches. Okay, so that means address latch enable, it is also active. That means it is 1 for during the T1 time. And what about the read? As it is a read operation, that means it is low during the from T2 to rest of the time, or the middle of the T2 to until the rest of the time. It's okay. You can make it low, and when it start floating, okay, towards the rest of the time. Okay, and data enable is also same. Data enable, it is also at the same time. I mean, when actually data are ready. So data ready, I mean, during from here to rest of the time. And what is the function of ready signal? So ready signal, you know, like, so as I said we normally need 4 clock pulse to finish the job. But sometimes this 4 clock pulse is not enough to finish the job. Okay, so then actually microprocessor send a ready signal before the T3. No, sorry, during the T3. During the T3 time, you can see during the T3 time, it send a control, send a signal, high signal, because ready is without bar. That means it makes a high signal during the T3 time, so that after the T3 there will be some extra pulse. This is called wait pulse, wait period, TW. So not T3, TW. TW, I mean wait pulse, you can say. Or so that means this ready signal, actually it is, if 4 clock pulse is not enough to finish the job, it needs, if it needs, that means it needs more clock pulse, then ready signal is active during the T3 time. So is it clear so far? Is it okay? Okay, now let me draw it. Let me draw it so that you will be clear, more clear. Okay, so here there are 4 states and T3 plus TW, and there is a I mean continue. I mean there is more something. That's why there is a gap. If we need more clock pass. Okay, so now you have to make a dotted line, because timing diagram, they should be nicely drawn. Okay, so now, okay, so first of all, as it is a, so yeah, um, yeah, so yeah, okay, so let us start from minimum. Or maximum with a bar. Okay, and it is a what kind of, okay, let us see. Yeah, okay, so if it is like move AL comma 2030, that means it is memory read operation, right? What will be the, I mean, yeah, so first of all, this read and write control signal, so that means it must be high, minimum for, it must be high for minimum mode throughout the time. Okay, it must be high. Okay, fine. And then what are the control signals we need? Okay, so address and data. AD not to AD 15. So this address and data. So actually, yeah. So they so during the T1 time only, they are for address, and then it is float condition for T2 times, then it becomes used for data. So that means at A not 2, A 15, and then it is for D not 2, T15. Okay, so this is about so here it is a float mode, floating condition, float. Float condition. Okay, so now it's about the ALE signal. ALE signal. So this signal is low during the T1 time, and the rest of the time it becomes, sorry, during the it is high, then rest of the time it is low. Okay, because this address information, they must be grabbed by the latches. Okay, and then what about the data enable? DEN. Data enable is this low signal. So it is used to grab, I mean it used to activate the buffer during for when the data are available, right? Oh, sorry, yeah, I make it opposite, I make it. So that means it must be low. Yeah, so that's it. During the data time it is low. And then what about the data transfer oblique receiver? So read operation, its data is coming to the microprocessor or uh, going out of the microprocessor. You can see here move AL comma to 0. So from memory read operation. So from memory to it's coming to the AL register. So AL register is microprocessor, part of the microprocessor. It is coming to the microprocessor. That means it is in receiver mode. Microprocessor in receiver mode. That means it becomes low. So let us start from high. High and then it becomes low. Oh, sorry. So I think no need. Okay. So not during the rest whole time. You can do it whole time because it is not related to address and data. I mean whole time. So whole time means whole time. Yeah. All right. So then what are the other signal? Is it a memory or input output related? Memory or IO? Okay, so as it is a memory related operation, that means it becomes a high. Okay, it should be a high signal all time. And if it is a input output related operation, then make it from high to low for whole time. Okay, and then what are the control signals left? What else? Read or write signal, right? So here actually we need a read control signal. Read, RD, it is for read and it is with a bar. Okay, so read as it is a read operation, so definitely I mean during the data time we can make it a low. Yeah. Okay, so this is a read operation. And what else left? What are the other control signals? Ready control signal. Okay, ready, R E A D Y. Small or capital letter doesn't matter. So sometimes capital letter or sometimes like small letter doesn't matter. Okay, so ready control signal, it must be if we need more clock pulse, it should be high during the T3 time so that there will be extra clock pulse provided after the T3. Okay, so this is all about like that. Is there any other control signal left? Any other signal? I think that is enough. Yeah, so that's all. Okay, there is another thing actually. Okay, let us write that one also. This is about a. So the address bus here until 15. So what about the 16? 16 to 19. A 16, a 16, a 16 slash S3 to a 19 slash S7. Okay, A16 to A19 or to slash A. So here how can the they are used for okay. So now here actually during the T1 time, same like this, here. So they are used for address. So address A16 to A19, and rest of the time it is for status signal as 3 to as 7. Okay, so is it clear, guys? Is it okay? Yeah, so I mean, yeah, this is about the read operation. If it is a memory read, then it is. If it is memory read, but if it is a input output read, like in AL comma something, so only the change is here actually. Only the change is here, here and here, because for input output case, we don't need the A6, A50, 16 to A19. This two is only the change. If it is for this two, for if it is like in AL comma, for example 30H, if it is like that, so only the one change is here and one change is, we don't need this one. At that time we don't need this one, because for input output port address cannot be more than 16 bit. Okay, so is it okay? Do you understand this thing? Clear? All of you clear this one? Okay, so let us discuss one thing, and then hopefully it will be more, it will be clear. So I can erase it, right? You take the note. I'm erasing. Okay. All right. Okay. Okay. Now it's about write operation. Okay, so 4 clock pulse and T3 plus T wait period. So yeah, this is, we already say what is the use of it. If 4 clock pulse is not enough, then it needs more clock pulse after T3. Okay, so for example, it is a out. Okay, so if it is like that, this is our instruction. Out 1030H, L. So this is the port address, right? 1030H, L. So data is, it is a write operation. So input output write operation. Input input output write operation. Not memory write operation, right? Input output write operation, and that's why it is out is there, write operation. Okay, so if it is like that, then what will be the control signal? First of all, minimum, or maximum. So definitely it is the minimum mode, because it is single processor system. It is in minimum mode. So minimum mode, it should be high. It should be high for all the time. Okay, it is in minimum mode. Then it's about IO, sorry, memory slash IO. And IO with a bar. So that means definitely, as it is an input output related operation, so definitely it must be low, right? So from high to low. Okay, all right. So now it's about address and data. Multiplex address and data, AD0 to AD15. To AD15. So during the T1 time, it's for address A0 to A15. And rest of the time it is for data. So there is no float mode here. Only the difference is here. One of the differences here, there is no float mode, because data is from the microprocessor. Uh, data is put on the data bus. So there is no float mode here. So D0 to D15. So during the T1 time, it is for address, and rest of the time it is for data. That's the main thing. Okay. So now again, what will be the ALE? ALE is high. ALE is high to activate the latch. Okay, activate the latch to grab the address information during the T1 time. During the T1 time, it is high, and rest of the time it is low. Okay, because during the address information during the T1 time, it must be grabbed by the latch. So ALE is to activate the latch. And what about the data enable? To activate the data buffer, right? DEN. Data enable, and it is with a bar. That means, so during the data time, it must be low. Must be low. Okay, so this is about, and then what else? Data transfer receiver. Data transfer / receiver. So look at here now, it is a transfer mode or receiver mode. Data is moving from microprocessor AL towards the port, or if it is related memory also. So from microprocessor, data will move. So that means it is in a transfer mode. Okay, so that means it is high for whole the time. All the time it is high. Okay, so now what else is a read operation or write operation? So they definitely it is a write operation. We need the write signal, and it is also with bar, and definitely during the data time it must be low. Must be low. Yeah, write signal. So okay, and another thing is left, ready. READY, ready control signal. and definitely if it needs more more clock period, then it should be high during the T1 time, so that it will generate more clock pulse. That's it. Is it okay to clear this one? This one is okay? Yeah. So look at here, it doesn't need this signal. This there is yeah. So A16 slash S3 to A19 slash S7. So this pins, this pin, I mean, we don't need it because during the input-output related operation, at the address cannot be more than 16 bit. Okay, so that's why this is not related during the input-output cases. As I said you before, again here also, that's why it is not shown here, because this is for input-output cases, input-out port address cannot be more than 16 bit. So that's why A16 to A19 is not a matter here. It's not it's not an issue here. So is it okay, right? All of you clear? Hmm? Okay, so here is the end of the syllabus. So let me summarize the things. Hmm. Yeah, let me finish, then I will say. Okay, so look at here. This is the summary of whole syllabus. So first of all, this is the latest chapter that we just discussed today. So function of some control signal like ALE, DEN, data transfer or receiver, and bank enable and ready. So these are the functions. So yeah, this is the then the timing diagram of control signal for memory or input output read operation. So read operation, if it is memory, what will be the change, and if input output, what? So only one or two change, so you know it. And timing diagram of control signal for memory or write operation. Like now I discuss about memory read operation and input output write operation. So you do understand now what will happen for input output read operation or memory write operation. Okay. And then 8255IC and input output interfacing. In this chapter, we discuss many examples. So just only four is here. One is DC operation control, DC motor operation control. One is stepper motor operation control. One is display like a set of character display like UOHB2019, for example, or LED switch interfacing. Okay, so these are the four example we discussed. We did it in the lab. Three we did it in the lab and also discuss in the lecture time. Okay, this is yeah, last two chapter. And then we have machine code plus control flow instruction. This is from measure 2. Control flow instruction and what we discussed during the measure 2 time, that is enough. And this is from measure 1. Homework 2, 3 plus data register and flag register. Okay, so this is from measure 1. From measure 1, so from measure 2, measure 2, okay, and that's it. Any question do you have here? So this is the material for what? This is the material for final. Is there any other exam except final? Measure 3 is there? This is the whole syllabus. You need more? You need more chapter? Okay, so then you can study study like interrupt chapter. This is also on the blackboard. Okay, so this is about the final. Yeah, so that's why this is the discounted final for final. Final exam. So yeah, and exam time, actually I already announced it on the blackboard. You also got the information. Yeah, so when will be the final? So it's April 25th. So and 9 o'clock in the morning, but room is not fixed yet. We'll decide. I mean, let us decide it first, and then you will be notified. Location. So this is until now. Yeah. Yeah. So yeah, definitely you can see these are all. Here there is no math, right? It is a program. It is theory. All the things you can say all are theory. Okay. There is no math. Is there any math here? No math. Yeah, so now what can I do? Yeah, give me suggestion. What can I do? Hmm? So this is the minimum. I mean, I try to try my best to make the things concise, more short. So what can I do more? No, it is comprehensive because yeah, if I delete it, so how can it be comprehensive? It is already, I'm shorted from measure 1. I just say homework 2 and 3, just basic information, data register and flag register. Okay, even so these are the as it is a yeah, hour 40 minutes. So yeah, definitely our question will be like that. Question will be made. Um, 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 a question will be made so that it I mean it must be solved. I mean it is solvable within 1 hour and 45 minutes. Definitely time will be time. I mean time will be considered. Not 1 more minute more than 1 hour 45 minutes. Okay, so you don't have to. I mean you need practice. Time definitely. I mean definitely all the things we cannot put in 1 hour 45 minutes, but question is comprehensive, so you have to This is in a short way comprehensive. Okay, so I mean we have to, I mean what we are instructed, what the instruction we got, we have to follow it, otherwise we'll be in trouble. Okay, so this is comprehensive. Okay, in a short way. Theory, guys, I already said you, these all the things are theory actually. There is no math. Is there any math here? So we cannot say this is theory or this is not theory. Like that actually. I mean, I do not understand. What do you mean theory? Theory is like okay. So define the function or write the function of ALE, for example, DN. Yeah, so write the function of ALE, DEN, data transfer receiver or bank high enable. These are the same. So definitely these are the things theory. And measure 1 and measure 2 you already finish it. So so definitely you know, understand what sort of question you got in the measure 1 and measure 2. It will be like that. Okay, so yeah, that's it. So that here actually, I mean, yeah, but this is in a concise way. I mean, this is in a short format. Yeah, all the things in a short way. I mean, I cannot. I mean, is there any other way I can? I mean, I cannot reduce it anymore. Actually, I don't know, but I cannot. Okay, so so you have a lab final tomorrow. You have a lab final, so see you then. Lab final. So I already discussed what about the lab final. I already discussed. So make preparation. Make I mean get prepared accordingly. And at 2 o'clock, all the student will start same like mid lab exam at the same time. Okay. Any other question? Okay. One more thing. One more thing is about the project. You know, I announced it on the blackboard about the project. You know, you have a 5% on the project. It is easy to get this 5%. So this project actually, this is also not a. I mean, I give you a easy project. Yeah, so it's not a big project. You know, it's very simple thing. You know, experiment number 8, I think. DC motor control. Yeah, by switch. So analog to digital converter. If you read the, I mean, maybe after the lab exam tomorrow, I will discuss. I mean, if you have any question, I will discuss with you. So let us finish the things. Okay, so many things are left. Project left, lab final left. So without this taking this thing, how can I make final? I mean, how can I give you to 70? I can make total out of 70. So this is a simple idea, right? Simple thing. Let us finish this thing. So definitely you will get before final, hopefully. So first of all, let us finish all the things. Okay, so about the project actually, so it's about the this, you know, the switch. So same like the idea of the sensor, you know, the light brightness control using the sensor. So sensor is a analog data. We have to convert it to the digital, and then we have to scale it down, and then we control. I mean, we control the LED on and off according to the value of the sensor data. Same thing for the DC motor control. DC motor is speed control. So speed will be low or high. It depends on the analog data. If, for example, analog data is low, speed is low, kind of like that. So try to read the manual. Project is like, at least you have to spend some hour, right? It's not like 5% you are getting without doing nothing. I mean, doing nothing. How? Yeah, it's not like that. Just read the experiment, read the lab manual, and then I am there and to help. But if you do not do anything, so at least do something. So it's a lab manual. You read the lab manual, and it's not in. I mean, it's similar idea like the last experiment we did. So this 5% actually, I mean, it's easy to get 5 out of 5. So okay, so is it okay, clear? So finish the project after the lab experiment. I mean, try to read the lab manual, and then maybe you can try to do it after the lab experiment. I mean, lab final. Something. Yes, but I am thinking about this project, this course. This course has one project, not two more projects. It has one project, so you have, yeah. This is also, I mean, then how can, so that the project will be, you want to get 0? No, it's no, this is yeah. It doesn't take long hour actually. I make the project. It's a easy project actually. So, but at least you have to do something. Okay, so otherwise how can I, so if I cannot remove it, this project is, I cannot remove it, how can, so then then that means you want to get 0 out of 5. So yeah, so I said that it is project is actually project, I want that finish the I mean uh, yeah, you finish the programming, and once it is working, then you are done. Just make a simple report with your program. Make a simple report with your program, and just lab manual, you know, based on the lab manual of that experiment, like a lab report. You know, same like a lab report, you can work in a group, and make one report from one group. That's it. Yeah, assembly language program. Yes, assembly language program. About the final, what do you mean? About the final already, I already discussed here. Here, microcomputer system, 8255 IC and input output interfacing, machine code plus control flow instruction, homework 2 and 3. Yeah, it's about Dr. Hussam. It's not about here. So all the courses are different. Here also make the things very short. Just homework 2 and 3. Homework 2 and 3 plus data register and flag register. It is very short things. So all the courses are separately. So things are made very concise here. Okay, so yeah, that's all. Yes, yeah. Any question? Okay. So see you inshallah tomorrow in the lab final exam. So okay, right?